Guys, have you heard of this quantum computing? It seems like there's an end of the digital era now, and we are entering into a new world of the rising quantum computer. This looks like a chandelier, and this is the future of the computing world, which is be alarmingly faster than we have it now, because this won't be it will all be in the cloud, and it will be so blazing fast that it's difficult to find an existing comparison, metaphor to explain things in every language. Computation that take years today will be done in like milliseconds, as qubits dance around in a divine symphony. As per Google, it's not far away. It's just that they're expecting that within 18 to 24 months, more than 2 years, the applications will be effective, and it's going to change everything, all the ways we deal with this computing, whether it's because in this symphony orchestra type, where every bit, every qubit in its own place play multiple notes. You just imagine a librarian. When there is one librarian, you look for your book, pick out one, and you will. But if there are hundreds, thousands of millions of librarians, each one looking for the book, it would be, at a breakneck speed. And computation it would be more nuanced, and it would be, allow us to have the large body of information in a flash, So this is IBM quantum computer. It's metallic cylinders. Inside cylinder is a spectacular array of gold plates. This is going to look like a chandelier with the wires and pipes suspended and then in the middle, kind of the core of the cylinder that we're staring at, is a real kind of beautiful structure of the metals that are like tiny shiny gold. Some copper material will be used. So we'll have those basically connected to the motherboard. Actually, that there won't be the motherboard as in a traditional sense. There will be a quantum processor inside. The bottom of the chandelier will be a single, very special computer chip. That chip will not be the one we're using now. That would be, so condensed, so powerful that it's a bit where the mysterious features of quantum physics are harnessed to deliver unprecedented processing power. The processing power will be so high that it like millions of seconds, through people building them. These golden chandeliers represent the coming revolution, real revolution computing, and future generations will be able to completely transform industries such as drug development, logistics, because now with the capacity that we have it now. Doing the researches and the development of drugs, it takes days and months to accumulate all the data, like DNA and genetic compositions. But there will be, it would be so fast that all mathematics problems previously thought impossible would be resolved and solved, and it's like a big scientific breakthrough, and the model of the universe will be presented as if we have never seen before. So unlike our existing computer work on 0s and 1s quantum computer will working on qubits. And qubits like an interim state between a 0 and to 1. It's anywhere in between. It's not either a 0 or 1. It's like building blocks, and every block in itself is independent. And unlike the classical computer we use now, they use bits, like string of ones and zeros, to encode information. Quantum computers use qubits, and qubits are bits like existing in a quantum state, which is a delicate state that makes them notoriously fragile. I mean, like, movement is so fast. This is the challenge that's being grappled with right now. And IBM and this progressively, impressively rapid, and it's likely that there will be a compositional structure where we'll have the shell, 5 casings like the white, these cans nest inside each other, act as a thermal shield, keeping everything super cold and vacuum sealed instead. There will be nerves like our brain nerves, and in our heads we have 3 billion nerves, and these photon carrying cables will deliver signals to and from the chip to drive qubit operations, return the measured results. So beneath the heart exchanges is the mixing chambers. So it's a complicated kind of structure where each bit of it will be functional, and these chambers they will be mixing inside different forms of liquid helium, and there will be helium-3, helium-4, and there will be evaporation and diffusing the heat. So because this is going to generate, the problem to this computer is that it creates loads of functions, but it gets heated because of the kind of chip, because the material, because of the component that we use, the conventional one. And there's a loss of energy transfer. But in this new ways of qubits, we'll have plenty of gold metallic chips, and there will be wires, and then all will be interlinked. There'll be chambers of the chambers, and this is going to be in the cloud. We won't be actually having any motherboard like a traditional computers we have. So we have quantum chemistry also coming in. Quantum itself means there's a huge, humongous amount of data will be stored, and we actually need for certain researchers huge amount of data. For example, we want to know about the space and galaxies and interstellar, their movements and the accuracies and the mathematics. So we need computing power that's beyond the present availability. Even the large language model that we are getting these days in the form of ChatGPT and all, they're almost using 3 billion characters, and they're churning out the text on the basis of 3 billion characters. So just imagine if we have more powers and more data transformation with an alarming pace, without the loss of the transmission, we'd be able to resolve so many issues which have been mysterious, and to help us calculate exactly even the fractions of the seconds and fractions of the distance. So this computing will be checking on the moves of the genome mapping. It still takes months for the genome mapping. It used to take years. Now with this powerful computing, probably we'll get to know about the DNA's codings and RNA's functions, and those diseases which have so far evaded the cure, and scientists have been befuddled, and because of the complexity, because of the data science that we need to. So hopefully it's estimation 2 years of this computing power, it will be like so revolutionary, and we would be able to harness maximum data entries and algorithms that will change the way so many industries working, including medical research, our other fields like genetic engineering, And there's plenty. I mean, it's like